Today in this video, we will discuss about transformation of functions. Well, let me take you to Chicago, the Millennium Park, and imagine you are just standing there in front of Cloud Gate and looking yourself into that marvelous elliptical stainless steel structure. That beam, if you look at, you see yourself in transformed forms, just change in shape. Sometimes you look funny at times and make you laugh. Well, we'll try to catch that picture and then imagine how many ways you can get transformed. Think you are the one standing in front of it and all those as your images. So in mathematics today, we will try to see a simpler form of this transformation and slowly and gradually develop some kind of equations to correlate the function and its images. Okay, let me get you back to a simple mirror. When you stand in front of a mirror, let's say 2 feet in front of the mirror, you see your image 2 feet behind the mirror. So it seems as if your position has been transformed behind the mirror. So what happens basically is, let's say this is the mirror. This is your position. You see your image here. So the transformation, if you see, it is horizontally, not vertically. So this is called horizontal translation. In case the mirror is like this, in that case you may see a reflection here and you get transformed vertically. So when you get transformed vertically, the x coordinate value remains same, but the y coordinate flips. So here, this is a simple case of reflection. There could be other kinds of transformations. For example, you are situated at a particular place and you move from there left or right. As you move left, your position changes and there is no change in the y position. Do you see? There is change only in x position. We call it horizontal translation. This horizontal translation could be left or could be right. Well, if you move up and down, then we call it vertical translation. When you do vertical translation, the x position remains same, but y position changes. Do you see that? That's how it is. So we saw a few transformations, and in all these transformations, shape remains constant. What changes? Position. So one kind of transformations which we just discussed is change in position, where shape remained constant. So in position we saw that there are a couple of changes. One is reflection, and then we have horizontal translation, or we can have vertical translation. And what did you notice in these things? In reflection, let us say if my coordinate point is here, and let me just name it x and y for the time being. Okay, reflection could also be horizontal or could be vertical. And if reflection is horizontal, in that case, what happens? The y value remains same, but x value changes. Correct? So the transformation is the x value changes to negative, right? Whatever it was, it becomes negative of that, and the y value remains same. Let's say at this point, let's say this point, and let's call this point as -5, 6. And if it gets reflected horizontally, then its reflection, which is the image of this point, will be what? Negative of this, which is 5, but 6 remains same. Do you see? Negative of this. So we could call horizontal reflection as change in x value. It becomes negative of x value, y remains same. But in case we take a reflection which is vertical, then what happens? Here the x value remains same, but y flips. right? So in this case, if x and y were the coordinates, then the image will have a coordinate with same x value but negative of y value. Well, these are our images, okay? So these are images. After transformation, and the type of transformation we just discussed is reflection. Reflection could be vertical or horizontal. If it is horizontal, then the x coordinate flips. If it is vertical, the y coordinate flips. Okay. Now we'll see what happens when we translate horizontally or vertically. Well, let's take an example. Let's go with the same coordinate points. Let's say xy. If I move it 1 unit to the right, what happens? Y value remains same, but the x value increases by 1. If I move it 5 units, it increases by 5. Let us say I translate by a units. In that case, it will increase by a. Okay? So let's assume that the horizontal translation we have taken moving right with a units. In that case, the x and y value changes to x plus a and y remains same. Do you see that? X plus a, where a is the horizontal movement by a units. If a is negative, it becomes minus a, right? Let's take an example. Again, let's go with this. Minus 5 and 6. If I move 2 units to right, okay, let's say we have minus 5 and 6 and we want to move 2 units right. What are going to be the coordinates of this? The y value will remain same, but here minus 5 plus 2. So this point gets transformed to minus 5 plus 2 units to the right will bring it to minus 3. Minus 3 to 6. You see that? So we basically added 2 to minus 5. Minus 5 plus 2. If we do 2 units left, then how will this point change? The image of this will come here. 2 units left, more negative. So it will be minus 7 and 6. Do you appreciate? Whenever we do horizontal translation, then what happens? The x value changes, not the y. So x and y are the original coordinates. If we change it, then the x value becomes plus a number of units. You translate it left or right. If you're moving left, we'll keep it minus a, okay? If you're moving right, we'll use it plus a. So I hope that is clear. And now let's see what happens for vertical translation, okay? Vertical translation. If our point is xy and we vertically translate it, then what happens to this point? Xy is the original point and the images, x value remains same this time, okay? But the y flips and y changes. Let's say we change vertically, move it up and down by b. Let's say you go up b units. Then what happens? The y increases by 2 units. Okay? So it becomes x y plus b. That becomes a new position. Let's take a point. Let's consider this time a point here. And let the coordinate of this point be 4 and 5. Now, if I move this unit up by 2, then what happens? The x value 4 remains same, but the y value becomes 7. Do you see that? Let's say it's here, up by 2. So the image will be 4 and 7. So there b was plus 2. If we move the point let's say 3 units down, then the original point, let's say, was xy, and we move 3 units down. What happens to y? It becomes y minus 3, and x remains same. So basically, we saw a few cases of translation, and in all these cases, we saw that the shape remains constant, but position changes. Now, position could change the value of x or the value of y. So whenever it was horizontal, then there was a change in x value. X changes. Y remains same. And for a vertical translation or reflection, x remains same. And what changes? The y value changes. Okay? So these were very simple cases where only change was in position. Shape remained. The image coordinates changed. Only one of them changed. If it was a horizontal transformation, then the x value, because horizontally when you move along the x coordinate parallel to it, right? But the y coordinate remains same. If you move along y coordinate vertically, then your position changes vertically, but the x position remains same, right? We'll do a set of 3 videos on transformations. Next video, I will teach you how dilation takes place. That means stretches and compression, both horizontal and vertical. And then in the third video, we'll take some examples and transform the functions. Okay? I hope you enjoyed and understood this concept of transformation. Thank you.